Hi, I'm Charles Smith. I'm on the docs team at Imply, and I write about Druid. We're here today with the Fireside chat with Rachel Pedreschi and Jon King, and we're here to talk about proof of concept issues that would pretty much anybody getting started with Druid would probably need to think about. Rachel and Jon, do you want to introduce yourself briefly, and then we'll just jump into it?
Yeah, sounds good. Hi, I'm Rachel Pedreschi. I run the community program here at Imply. And what I mean by the community program is that it's my responsibility to grow the Apache Druid community from everything from awareness through adoption and then eventually advocacy. So a big part of our job is to help people who are working with open source Druid in the wild be successful with it, and then help them get into production and get them to talk about it.
Thank you very much. Jon?
I'm Jon King. I'm a principal field architect here at Imply. Been here for a couple of years now. My role is the technical journey during the proof of concept. So I'm the one that helps with designing the systems, working through ingestion and querying, and working with our larger team as a whole as a support mechanism.
Thank you very much. And thank you both for joining today and helping talk about these issues that folks will run into as they're getting started with Druid. And the first topic that we had on our list was cluster sizing. And my first question about it, either Jon or Rachel, is how frequently do you see issues that could have been avoided if the cluster had been properly sized in the first place?
I don't know. I would say 80-90% of every performance issue.
Yeah, I would say that that's true. So it breaks down into three different ways. The ingestion, the amount of resources for ingestion, the amount of resources for storage, as well as the amount of resources for querying. And naturally, most people are pretty conservative on those, and that they end up usually oversubscribing those resources quite significantly.
And the thing to keep in mind is that Apache Druid is a microservices based architecture. And so that is notoriously complex for managing and sizing. I mean, it gives you sort of infinite power because you can, all those different processes are so flexible. But at the same time, there's so many places that there's roadblocks or bottlenecks or problems that can be solved. And I would say the biggest thing to keep in mind is before you start tuning knobs, it's better to go look at expanding the amount of resources that are available to those processes rather than trying to tune individual knobs. That would be my overall suggestion to anybody listening to this.
Yeah,
add resources before you start tuning stuff.
Yeah, I agree. It's usually a matter of adding resources versus less about actually tuning the knobs and tuning the sockets, the threads, or things like that. Sometimes that adds incremental progress, but really it comes down to most of the time we just see that people just need to add CPU and resources.
So I'm thinking though, I've got to figure out how to start somewhere, right? And so if I am just getting started and I want to, I've already forgotten the three areas that you talked about because I should have written it down. You said ingestion,
storage,
and querying.
Yes.
So can we think about the approach that I would take if I'm just getting started and I want to say, I got to spin up enough to get this thing going? What do I need to think about to handle these three separate areas?
Yeah, exactly.
I wanted to start at the high level of just your node types. So there are three Imply specified node types that have different processes available to them. There are data nodes that include the historical and the middle manager processes. There are the brokers, which include the broker and the router process. And then there are the master nodes that include the coordinator and the overlord processes, I think. Don't quote me on any of that. I could have put them in the wrong places. So in general, your data nodes are going to be where you want a direct attached storage. And I will allow Jon to sort of give clear indications on why that's good and what type of direct attached storage you want. But that's going to be based on the data and how well it compresses and rolls up into a segment file. So you basically need enough storage to store the data. Then you need enough RAM on top of that when you query. So that's for ingestion. So before querying on those data nodes, you're going to need to make sure you have enough RAM so that the data can be loaded into memory as these queries are being executed. So typically, those are going to be your beefiest nodes. And I would say 9 times out of 10, those are going to be CPU constraint, because there's a lot of things, and things being the technical term in Druid, that are single threaded, where one CPU does one type of work. And in order to get it to do more work, you need more CPU. So those historical nodes need to be pretty well sized and need to have direct attached storage that is preferably fast and has very low network latency, and that it's well sized in terms of CPU and storage. The rule of thumb, and Jon, correct me if I'm wrong on this one, is about 10,000 records per second per core in terms of ingest speed. Again, your miles may vary, but that's a place to start.
Yeah.
Your master nodes can start fairly small. Yeah, go on.
No, I was saying you're right.
Okay. Your master nodes start fairly small, and you only need 3 of those for a highly available architecture. I wouldn't recommend doing 1, so it's 1 or 3. And those can, we usually say like an M3s, or they don't have to be big, but you will grow those up. You never need more of those. You will grow data nodes out. So you add more data nodes as you need more capacity, or you need more speed. The last type of nodes are the broker nodes, and the rule of thumb there is that they're typically fairly small, that you want to have a lot of CPU and RAM on those. You don't need a lot of storage, but you do 1 of those for every 10 to 15 data nodes. That's where I would start. Let Jon add any other color he wants.
Yeah, and just to add on to more what you're talking about, like why we like direct attached storage. First of all, it keeps the data really close to the CPU, so you're only communicating over the PCI bus. Versus what we've seen with block storage, things like EBS and some of the other cloud providers is, what happens is when we go to Druid, when Druid says, "Hey, I need a bunch of data," it goes and asks these block storage for a whole bunch of data. The block storage says, "Cool, I'll go get it," and then it just goes out to lunch. We don't see anything coming back over the wire. It's really strange. It's like we DDoSed our own block storage. We recommend direct, like NVMe storage, SSD storage. I would not recommend spending disk storage. Always keep it on the fastest storage. It is a database, so please treat it like a database as you would a modern database. And if you do have to go with the block attached storage, choose one with as many IOPS as you possibly can. The GP2s that we see don't have enough IOPS for really heavy workloads. Those are the ones that typically go out to lunch.
So this talk will become a resource, but are there any other resources that you find valuable when you're doing these sizing things? Are there any docs that are especially helpful or not helpful? We're here to help improve those. Is there anything that, if someone has a question, is there a resource that they can go to help them think about sizing?
There are sizing docs out there. I think the biggest thing that, especially when I came on board here, there were 2 things that I learned. One was how fast can we ingest data from a streaming process? Like Rachel said, that's about 10,000 records per second. It might go up to 20 if your rows are small, but generally on the low side about 10,000. But on the querying side, so now we've taken the data in, we've optimized it, and we need to get access to that data, giving users access to that data. The one that Rachel was during our training, she said a CPU can handle about 4 gigs per second when the data is optimized. And so that's a good place to start when you're talking about looking at the number of CPUs. Like Rachel said, that most of the workloads that we run into on Druid are CPU bound. So this is a good place to start. Think about 4 gigs per second per vCPU when you're looking at sizing those historical nodes. So if I've got, let's say I've got, let's keep it simple, 8 gigs of data, segment files that I need to scan through in a second. I need 2 CPUs for that, right? And then we come into the compounding side of that is how many of these queries am I running in parallel at the same time? And let's say that's 10. So now we know very roughly, we know we need about 20 vCPUs on this system to handle that, 80 gigs of throughput per second. Just knowing some of the boundaries is, the guardrails is good. Like where do things just cap out?
We do need to create a document, Charles, that explains this well and makes it accessible to people, because this is a question that comes up in our open source forums all the time. When a customer is engaging with a sales engineer, the sales engineer has a luxury of being able to talk to them about this and having that kind of collaborative ongoing conversation, because the sizing calculator doesn't supposed to spit out a number. What it's supposed to be doing is creating a platform for you to have a conversation with the customer about what their goals are, what their SLAs are. Do you want to save money? Do you want more data? Do you want to store it for longer? Do you want to have more dashboards? Like, all of those questions affect the overall output. And then, of course, your mileage may vary. You got to try it out. Got to test it.
I had a quick related question. We probably need to move on to the next topic, but just for that, Rachel, you hit on something that I was interested in. Who are the types of people at the customer who have that information that you're talking to? Like, who are you typically getting that information from?
Well, in the case, Jon, why don't you answer this?
So usually we're finding that data either from data engineering, data platform, or product. I'd say those are the three best places to start. Yeah,
wherever you can is the answer. Wherever you can get those answers, because they're essential. They're essential to the success of any Druid implementation and any application that you build on Druid. Like, those things should be table stakes. You should know where your data is coming from, what format is it in, and how long you need to retain that data. I mean, typically a product manager or an architect would be the person I would be hoping that would have that information.
This is awesome. I think that this is a really good place to start, and hopefully people will, be able to use this information about cluster sizing just to unblock the questions so they can move on. I think that it kind of goes well into our next topic, which we're going to talk about architecture. So is there anything moving into an architecture discussion that you need to think about more as far as planning?
So sizing is one part of it, but then as we get into architectures, we get into data architectures and things like that. That's where the real nuances come in. Sometimes we'll see data that comes in really like very linear, like not a lot of skew in the data, not a lot, like data time's not out of order. And so it just kind of nicely flows in, works really well on the system. What we've run into lately is as we expand into more beyond our traditional realms, we're seeing a lot of data that's being like backfilled, a lot of data that's out of order. This creates a lot of intermediate segments in the indexers, which typically leads to out of memory. So what we're doing within the SE team and is training back out on this is when we start to see this, we recognize these, the easiest way to overcome that is to just increase the segment granularity. So sometimes you'll say it's a day, increase that to a month, just so you have less segment files being created, right? And then what you can do is you can take, once you get the data in, then you can do a re-ingest and make that into your final data format.
Let's just briefly go into a segment in that sense and the granularity, just in case somebody's joining with no concept of what the segment is. Just a brief description of the way that we store things in segments.
Oh boy, that's a fairly long conversation, but I'll do my best to summarize. So a segment file is basically a time-ordered, time-bounded set of data. And it says, here's my start time, here's my end time. And it has, based on, then we get into partitioning, but let's assume that we just have one segment file. And that one basically says, here's my start time, here's my end time. And in that file, I have all of the data that's associated with that time that was created. And so since Druid is mostly based around time series, things like that, our primary filter is time. So what that does is we know the time bounds of those files. We can do segment pruning as we're looking through the data. So like, let's say I want the last day's worth of data. I don't have to read through all of my data within in the system. I can just look at those segments that meet that need. But also within the file, we do some neat tricks. We have a dictionary encoding. So we're not storing the raw string over and over again. We'll assign that an ID, and we'll store that ID in the column, as well as we're using bitmap indexes to further summarize data and to find data faster if we have a filter on that.
I was going to just to continue, because one of the things that is overlooked, I think, a lot while people who are new to Druid is the concept of rollup. And the Druid will roll the data up to the lowest level granularity that it can by default, unless you turn it off. And you want it to do this. If you have some high cardinality columns, there are ways to manage that through sketches. And again, highly recommend that people who are doing this, that they don't just accept the fact that their data might not roll up perfectly or might not roll up tightly to save space, because that really is a superpower of Druids. And so when you're talking about segment granularity, that has a lot to do with how the data is rolled up and what ends up in a single segment, and then how tightly is that data rolled up. Just wanted to make sure that we brought that up in terms of the segments, even though it's not directly related to what a segment file is.
Yeah, that's one of the coolest things about ingest, is being able to do those rollups in line in real time and not having to do those upstream in an ETL system, which further reduces the time that it takes to get data. That's one of the, when I came on board, I saw that, I'm like, that's one of the coolest things I've ever seen. And when you're talking to data engineers, when you're talking to data platform teams, they're typically looking for ways to, collapse down that pipeline and make their life easier. Rollups are a huge part of most ETL pipelines, and it makes it super easy just to say, oh yeah, we'll take that out of Spark, we'll take that out of whatever your upstream system is, we'll put it in Druid, right? That's done. Super easy.
And there's very few use cases where you do need to see microsecond level data. Like it's just not human actionable in any way. So it's a really, really important concept that I don't think people understand or take advantage of anywhere near enough. So if you're starting out, make sure you think about rolling up your data properly from the get-go.
I actually want to do one of these dedicated to Rollup. Like I think that it would be great to figure out a way to talk about that, just for all these reasons. Like, this is unique and it's really powerful. And if you don't do it, you're going to have so much data, you're not going to know what to do with it. I know it's kind of forward looking, but I would like to have a Rollup talk if you guys want to sign up for that.
Peter did a really nice video on it, actually. If you've not seen that one, Peter does a great video too. I can send a link in the show notes.
That is perfect. That would be awesome. The thing that I'm wondering here is, how do I know that I've run into trouble with my architecture as far as like data wise? Like what? So it sounds like out of memory is something that I would hit. Are there any other things that are just big red flags that I'm like, oh, I should have done this different?
If you have too many joins.
Yeah.
If you're all of a sudden joining all your data all over the place, you have to go back and rethink the data model. I mean, that in itself is probably worth a number of these talks, is just actually getting your data model right from the get-go. Yep. So.
Yeah, we've been talking about joins, and joins are something that are expensive to do over and over and over again. Do those upstream once, right? And save all that compute for running your queries. So sometimes it does take that hard conversation with POCs and customers to say, hey, you need to architect upstream to save downstream and to get performance downstream. So slow down to speed up, right?
I think that's important. And I think it's like, it affects a lot of people that are coming from the old RDBMS kind of situation where everything was all highly normalized and all of that kind of thing.
We have to go flat. We're going for flat, not denormalized. So sometimes there's this tendency, even internally, to talk about denormalized data. And we don't even want denormalized data if you're talking to us old people. We want flat data.
Is there a nuance that you need to call out between denormalized and flat just to help clarify that bit, or is that its own talk too?
Not really. So denormalized data traditionally would be taking a third normal form schema that an OLTP system would be writing in an RDMS world.
Right.
And denormalizing it into a star or a snowflake style schema, which was the more traditional way of creating a schema that's designed for analytics or OLAP type of processing. Druid is the modern architecture here. And you want to take that star schema and then collapse it even further into a flat table. Now, the reason why we normalized data back in the 70s was to save disk space, because disk was really expensive. Disk is now a lot cheaper.
Right.
And so the benefits of flattening your data greatly outweigh your, and if you want to think of it as a trade-off, and this is a point Jon was making earlier, that your rolling up the data keeps you from having to do downstream ETL or aggregation tables and maintaining those aggregation tables, or creating I used to call it a shrunken star or an aggregated star that sits on top of your star schema. So yes, so Druid is going to give you that, but there's always takes. And so what we want is a very flat schema in order to do this really well. And then we've added a lot, as I mentioned, a lot of cool technology in order to make that work particularly well. But thinking about it that way is that you're going to get roll up, you're going to get compression, but you have to give it a fully denormalized schema or a flattened schema.
I really like the fact that you're talking about it that way, because it's not just telling you what to do. It's giving you the reasoning, like you do have to do some work ahead of time, but then it's really going to pay off in the end as far as taking advantage of what Druid has to offer, and why it exists, basically.
On older databases, it used to be always be afraid of table scans. Never do a table scan, right? Because it takes one CPU forever to go through that table. But on a distributed system, now you can break that table apart. And you can have any number of CPUs working on that. So don't be afraid of table scans anymore. And like Rachel's saying, joins are expensive. Denormalize those. Table scans are wicked fast now.
And Druid is designed to table scan. There's other NoSQL databases, and I wouldn't necessarily call Druid a NoSQL database, but like key value stores don't table scan well. Those do other things well. So let's be very clear about that now, that not all of these databases fall into this place. This is a superpower of Druids is table scanning, which is super useful when you're trying to do ad hoc or conversational style analytics.
Have you ever tried to do a table scan on HBase or Cassandra?
Oh, I have on Cassandra. I've written an entire blog post on why you don't want a table scan on Cassandra, which again is good for other things, not good for table scanning. And you can put as much lipstick on that pig as you want. But
yeah, we've seen several POCs over recently where people are coming from HBase saying, "Oh, it was great whenever I wanted like these point and scans, but I still have to change my schema upstream every time that somebody asks a new question. I want something that's more flexible." Okay, well, come to table scans. We have cookies.
That's what we designed. Like, yeah, come to the light side, not the dark side. But that is exactly why Druid exists. And
so, what are the red flags or the yellow flags that let me know that I've done something wrong? So it sounds like if I'm writing a bunch of joins, I've done it wrong. Are there other kind of symptoms that I can look for that I could think of, like, really, I could have made it better? What else do you think of when you think you kind of need to redo?
If you're really thinking that you're going to manipulate the data in your SQL statement, then you've got another thing coming. Like, go back and look at your data pipeline. I think a lot of people, especially when they come from certain technologies, are used to working with platforms. They're familiar with this idea: just shove the data in, or data lakes. Shove the data in, and we'll figure it out on the way out. And this is a post-data lake mentality. We're not trying to figure it out on the way out. We're trying to figure it out on the way in. And that is a massive mentality shift again for people. So if you're trying to do weird or natural things, and you're doing not just joins, but subqueries, or, highly complicated stuff, again, stuff is a technical term, on your queries, again, you're probably looking at your data model incorrectly.
I think that this probably plays in with our next topic really well, which is talking about using the right queries, because we're going to get into somewhat like sessionized data too. But I was thinking, if I'm thinking about the queries that I expect my users to run, if they have a lot of these joins, subqueries, and that kind of thing, is this something that I could have just answered one time on the way in, so that we're not having to redo it over and over?
I would want to say something about architecture, which is kind of unrelated, but make sure you have access to the logs that your cloud provider or your internal cloud provider can give you. Because also, when Druid gives you an error message, it's typically not the error message that you need. You usually have to kind of go through even the Druid logs to figure out where the real error message is. And until you're really comfortable with how these microservices interact with each other, you don't really know where you're supposed to be looking, right? You just see your ingestion failed. Well, where should you look? Well, probably the middle manager log or the historical log, because those are going to be where those real errors are coming from. But then there's a whole other layer of the logs from the system that this is running on. And if you don't have access to them, you're kind of blind in terms of, maybe resource allocations or I'm thinking that that situation that just happened yesterday where, the cloud vendor just shut down, just completely changed a particular setting that screwed up their entire Druid cluster, but we wouldn't have known. It was very difficult to troubleshoot unless we had access to those. And I know it sounds like a really simple ask. Amazing how often it gets overlooked.
Yeah, exactly. I mean, so there's the logs of what the system is doing, but there's also underlying logs, like what the resources are doing. And that's how we found this issue with the EBS volumes is we were running queries and I was running DStat, which, is a really nice tool for aggregating stats on the system. And we saw the disk shoot to 100% and it just stayed there, but then the network just did nothing. So sometimes you do have to dig a little bit deeper into understanding what the system is doing as opposed to what the application is doing. That can be more difficult. Yeah. But Rachel is right. Sometimes, inside the logs, there's multiple levels of who's managing what. We run into things where, hey, this task was shut down. Why did it shut down? There's no errors. There's no errors being logged. And then we got to go up to the overlord or the middle manager to find out, what was that application thinking when it shut down? Why did it shut down that task?
I think
and performance too, and sizing, right? Doing a PS minus EF is actually still a very relevant thing that you want to see. Are you running out of memory somewhere? Yeah. Or are you bottlenecked? Is your deep storage full? There's so many places where the operating system only person can tell you this information.
I think that we definitely want to have one of these just on that whole methodology. Where do I look first? What is the next thing? I think that it may feel like a little bit more training focused than this kind of just casual chat focused. But I think that definitely, and especially for someone like me, I deal with Druid kind of in its isolated form. I don't get to see it in the wild as much. So I really am interested in that. When it's running in real life, do the problems happen? And how do I dig into that to figure out where I've taken a wrong turn? Or who knows, my cloud provider changed a setting on me and, and I didn't even know it.
Or, you had 3 instances disappear because that's what cloud providers do.
Right.
What just happened here?
I think that as not just a customer, but as someone who's dealing with this kind of setup, it kind of gives you a sense of not having control. If you don't have the access or the tools to kind of dig into those spaces and know what you're looking for, you just feel like this is out of my control. I don't know how to figure it out. But the answers are there. You just need some help learning how to find them, right?
Yeah. Distributed systems are overwhelming to begin with, right? Especially with the amount of chatter and gossip that Druid has. Who's managing what, who's talking to who, when did they talk to each other, and above, what are the resources doing? What are my disks doing? What's my memory doing? Do I have, heaven forbid, do I have a degraded hardware, right? That's doing something underneath that's just slower. It is hard. And I won't discount that in any way. It is extremely hard, but once you go through a couple of these cycles, it gets a lot easier. And tasks are talking to the overlord, historicals are talking to the coordinator, peons are talking to the coordinator, middle manager. Then you just start to intuitively know like what should I be looking at? You get this kind of like sixth sense of what's going on.
We're developing Druid ESP through these things.
We just need like a common Kafka stream that we just subscribe to, right? AKA telepathy.
Oh my goodness. Moving on to querying. So what tips do we have for folks as far as querying that to help them get started and what they need to be thinking about?
From the performance side, we'll go back, going back to that 4 gigs per second, able to scan that. But we have 3 different types of queries that we run. One is the top in. That's when I have one dimension. I'm doing some type of aggregation on that, and that'll pull a certain number of rows from each historical and then aggregate those on the broker. Group bys are when I have more columns that I'm dimensioning by. Top ends are fast. Group bys are extremely powerful. We have done a lot of work with vectorization. We've done a lot of work with parallel work on those. Extremely powerful. And then we have, is it scans now, Rachel? Scans?
Yeah.
We changed over the last year. So we have scans now, which are just basically saying, hey, go get me all the data between this time and that time and apply these filters to it. So each one of them is very useful in its own context. I tend to favor group bys because they have more tunables and they're way more powerful with vectorization now.
And let's take a step back here. And what Jon's talking about is actually the underlying way that data is queried out of Druid. The standard for doing those queries is SQL. But you need to recognize there is a native query language that sits under SQL, which doesn't have a name, but I've always wanted to call it Rune. But anyway, just throwing that out there. And that's what's doing. And so understanding that when you write a SQL query, it's being translated into a native Druid language. And you can use an explain keyword to see what that is. But even that requires some experience with, what Jon was talking about. Is this a Tombat query? Is it a group by query? Is it a scan query? But doing that a few times on some very simple queries as you're building up your query foo on your data source and seeing what's happening in the native language is really, really helpful in terms of troubleshooting down the line, because as your queries do become more complicated, why is it that the group by isn't getting pushed down correctly or whatever it happens to be, you're able to see that better in the query plan. Now, the next step of all that is sometime what you have to get used to doing too in terms of query performance is doing something called a flame graph. And this scares a lot of people because it requires a Java toolkit to generate a flame graph. But the flame graph, again, once you understand the different processes it involves, will tell you where your query is being bottlenecked. And can help you make decisions. And this is very, very advanced Druiding. Let's be clear. But the more people that do it and get comfortable with it, the more this knowledge is going to get spread out. Especially if you're going to be, if you found an undocumented feature in the product, or the only bug that Druid's ever had in this, the team, when you create a ticket around it, would appreciate that level of debugging information. So I went way down into the weeds, but it's still stuff that needs to be talked about that we don't talk about enough.
Let's wade just a hint out of the weeds a bit. So the flame graph stuff, we could probably, I'm sure there's some advanced sort of resource that you would need to deal with that. If there isn't, is it documented or it's all just kind of?
We're working on it.
Okay.
I'm working with engineering on getting not just how to create a flame graph. That's been documented. That's easy to find. How to read it and understand it and interpret it. That's something that's training that does need to be created and is at least thought about doing. But not we've done it yet.
Yeah. But let's go back up, because the thing is that the explain plan is something anybody can do. Are there any things to help people just with that beginning? Is there any sort of tutorial on that? Or that sounds like it might be a good querying 101, 102 type thing to get people into. I know that we want people to be able to use SQL as much as they can, but it sounds like having that extra bit of knowledge and what's happening with the native query language can really make it more powerful and just help you understand what's happening under the covers a little bit.
I think part of that's also understanding like just how any database would work in certain SQL with certain SQL. If you have a lot of subqueries, things like that, that data's got to be that data has to be materialized, and then it's got to be spread throughout the system, right? So you want to minimize those. You want to minimize the materialization that happens as much as possible. Just little things like that. There's always games you can play with the optimizer, especially our optimizer. But Rachel's right. Like start small. Don't be afraid to start small. Like just do select count, look at the explain plan, get a little bit more familiar with like, am I running a top in? Am I running a group by? Can I enable vectorization on this? Set vectorization to force, see where it blows up, things like that. Find the boundaries, and then things get a lot easier from there.
So I'm wondering, like if I'm under pressure to get a system running pretty quickly, I'm just wondering, are there some tips or tricks or methodology that I could take from the queries I expect to run to pare them back? Like is there a way to take something that looks somewhat more complex and just try it bit by bit or anything like that? Like, what do you think about there? Like any insights or?
Oh my goodness. If I had a nickel every time I told people to like saying, can you just make sure your subquery works first before you try to put it into the main query? Like, like seriously, little things like that really go a long way. So you have to be iterative in terms of your query building to make sure that even that the data types that you're working with, that you think you're working with, are the ones that you're working with. It could be even as simple as that you have the wrong data type that you're trying to manipulate and you're wondering why it's not working. So yeah, definitely start small and piece out your query as you troubleshoot it.
Yeah, that's a big part, is just break down your query, see where the bottleneck is, because sometimes people think, oh, it's at the highest level, and it's actually this one little piece that's way down in there that's taking a long time to get through. Sessionized data is that way. Sessionized data is having to roll all that data up into what somebody expects as a unique session is very interesting.
I know that this was kind of one of the particular sticking points with sessionized data. Are there any particular tips or tricks or just approaches to dealing with that help people be successful that you can think of? Like, here I am. I know I'm going to have to deal with sessionized data. What are my things that I should think about in the first place?
I think that well, first you should be thinking about the scale. If it's small sessionized data, maybe a couple 100,000 rows, and it's not going to grow much beyond that, then I think that's okay. But if you're talking like millions or tens of millions or billions, then you need to think your upstream architecture. So that's usually where we would recommend, like Kafka. Kafka has some tools for sessionizing that. Flink has some tools for sessionizing that. But we have to gauge on what their upstream team is able to handle and what their upstream architecture looks like. But most of the time we try and get that push that upstream. So maybe they'll either do windowing upstream or they'll do aggregation upstream on those, or sometimes they have to just write a Spark job to kind of condense those down and then push that into Druid.
It sounds like if we had like an example of that, it would be good for folks to just kind of see where the benefit lies in that. I think some of that may be in the work. Any other thing that you guys can think about queries before we wrap this session up?
I would say if you have a query that you think is running slow, don't be afraid to reach out and say, hey, can I get a second set of eyes on this? Or even a third set of eyes. Everybody, we all process data a little bit differently. We all have different experiences. So sometimes you may try it with a with statement, or you might try it this way, or say, hey, collapse these down into a single, like they share a lot of commonalities. Don't run multiple queries, run a single query with all the, this filter in there. But you're not alone. Don't ever think that you're alone. You have a whole team behind you. So please reach out if you think something is slow, if something isn't passing the sniff test, then reach out. FieldEng is an awesome place that pretty much most of our technical people hang out on that. A lot of us like working through these, SQL challenges, the query challenges. It's a lot of fun.
They are fun. And this isn't Oracle. Like, we don't have, there wasn't billions of people looking at these particular queries in the optimizer over the course of these years. I mean, a lot of this information is siloed and, in a few people's heads. And again, the more we talk about a situation, the more that information gets disseminated and we can go deeper and deeper into it. So yeah, just like Jon said, you're not alone and you're not dumb. You know, our optimizer in a lot of ways is dumb at this point.
So if I don't work at Imply, I could go to the forum to post a question about my query or something like that.
Druid forum would be a great place to go.
I think that's great. I'm gonna go ahead and stop the recording unless you guys have any last comments before I just end the recording portion.
No, but thanks for taking the time.
Yeah, this has been great, Charles.